Have you ever seen a block of ice creating thick white smoke like something straight out of a science fiction movie? The strange thing is, this smoking ice never melts into water like normal ice. It simply gets smaller and slowly disappears into the air, while the cold fog keeps pouring out around it. This unusual type of ice is so cold that it can burn human skin, yet at the same time, it is used to transport vaccines and frozen goods all over the world. But what exactly is dry ice? And why do humans freeze an invisible gas into these dangerous blocks of ice? Few people realize that this strange, smoking ice was actually discovered nearly 200 years ago. In 1835, scientists first found that carbon dioxide could be compressed into a liquid and then frozen into a solid at extremely low temperatures. But at that time, dry ice was little more than a strange scientific experiment because refrigeration and gas compression technology were still very limited. It was not until the early 20th century, when the refrigeration industry began rapidly expanding, that people realized this special form of ice could completely transform the way food and goods were transported and preserved. From a rare laboratory phenomenon, dry ice gradually became an important part of modern logistics. And today, join Mido Explained as we explore the strange science behind this mysterious frozen material. Even though it is called ice, dry ice is not made from water at all. It is actually solid carbon dioxide, the same CO2 gas that humans breathe out every day, frozen at an extremely low temperature. Normally, CO2 is an invisible gas that exists everywhere in the air around us. But when it is compressed under very high pressure and cooled down to around -109 degrees Fahrenheit, it begins turning into a white solid that looks like a block of ice. What makes this ice even stranger is that it almost never exists naturally on Earth. And unlike normal ice, when it warms up, it does not melt into liquid water. Instead, it turns directly back into gas and disappears into the surrounding air. Before watching this video, what did you think dry ice actually was? Share your interesting thoughts in the comments below. We and the other viewers would love to read your answers. Believe it or not, most dry ice today actually begins as industrial waste gas. In many chemical plants, breweries, and fertilizer factories, large amounts of carbon dioxide are constantly produced as a byproduct. Instead of releasing all of that gas directly into the atmosphere, industries began capturing it to make dry ice. First, the CO2 is cleaned to remove dust and moisture before entering extremely high-pressure compression systems. As the gas is compressed and cooled, the invisible CO2 gradually turns into a liquid. Then, the pressure is suddenly released, causing part of the liquid carbon dioxide to instantly freeze into an extremely cold white snow. Finally, this frozen CO2 snow is compressed into the solid blocks of dry ice that we see today. Unlike normal ice that melts into water when left outside, dry ice disappears in a completely different way. As the surrounding temperature rises, this frozen CO2 does not turn into liquid. Instead, it changes directly into gas and escapes into the air. This process is called sublimation. The reason is that under normal atmospheric pressure on Earth, carbon dioxide can barely exist in liquid form. That also means every block of dry ice is constantly evaporating into gas, even when you cannot see it happening. This is why dry ice does not leave puddles of water behind, like regular ice, and has become extremely useful for cold transportation and shipping. But at the same time, it also makes dry ice much harder to store compared to normal ice. Have you ever wondered why dry ice creates such thick white smoke? What you are actually seeing is not smoke, or even carbon dioxide gas at all. As dry ice begins evaporating, the extremely cold CO2 gas around it rapidly cools the moisture already present in the air. Tiny water droplets instantly condense into a thick white fog that our eyes can see. The effect is similar to seeing your breath on a cold winter day, but much more intense because dry ice is around -109 degrees Fahrenheit. And since cold carbon dioxide gas is heavier than normal air, this fog usually flows downward and spreads across the ground instead of rising like normal hot smoke. Imagine dropping a block of dry ice into hot water. Within seconds, thick white fog suddenly bursts out like a miniature smoke machine. But what is actually happening here? When dry ice comes into contact with hot water, heat transfers into the frozen CO2 much faster, causing the solid carbon dioxide to turn into gas at an extremely high speed. The more cold gas that escapes, the more moisture in the surrounding air gets cooled and condensed into dense white fog. That is why hotter water creates a much stronger smoke effect. In many stage performances and movie productions, people intentionally combine hot water with dry ice to create massive clouds of fog that crawl across the ground without using industrial smoke machines. Most people think dry ice is just a fun experiment used to create smoke effects. But in reality, it is one of the most dangerously cold materials that humans can handle directly with their bare hands. At such an extremely low temperature, dry ice is cold enough to freeze human skin within only a few seconds of contact. That is why protective gloves are always required when handling dry ice in factories or laboratories. But even more dangerous than the cold itself is the invisible CO2 gas that dry ice constantly releases as it evaporates. In enclosed spaces, carbon dioxide can slowly build up and replace oxygen in the air without people even realizing it, because the gas is completely colorless and odorless. You might think that something as strange as dry ice must exist naturally somewhere on Earth. But in reality, the opposite is almost true. Under normal atmospheric conditions, carbon dioxide has a very difficult time existing in solid form because Earth simply is not cold enough. Even in Antarctica, where temperatures can fall below -100 degrees Fahrenheit, naturally occurring dry ice is still extremely rare. That is why almost all dry ice used around the world today has to be produced using industrial machinery. But on Mars, things are completely different. Since the planet's atmosphere is made of around 95% carbon dioxide and temperatures are far colder, the polar regions of Mars actually contain massive seasonal layers of natural carbon dioxide ice. Today, dry ice has become an almost essential part of the global cold transportation system. Every day, millions of pounds of frozen food, vaccines, and biological samples are shipped around the world inside containers filled with dry ice. Unlike regular ice, dry ice does not melt into water, so it does not soak or damage products during transportation. This is a huge advantage for long-distance flights and modern logistics systems. During the COVID-19 pandemic, global demand for dry ice surged because many vaccines needed to be stored at extremely low temperatures throughout the shipping process. From small laboratory containers to massive airport cargo facilities, dry ice is quietly helping the global cold supply chain operate every single day. You may be surprised to learn that dry ice is now even used to clean aircraft engines and massive industrial machinery inside factories. Many modern maintenance centers use a technology called dry ice blasting, to clean industrial equipment. Small dry ice pellets are fired at extremely high speed to remove grease, dirt, and built-up residue from metal surfaces. But unlike sandblasting or high-pressure water cleaning, dry ice leaves almost no waste behind after the process. The moment the frozen CO2 pellets hit the surface, they instantly turn back into gas and disappear into the air. That is why this method is often used in the aviation industry, food production, and modern industrial systems where water or harsh chemicals could damage sensitive equipment. During the global vaccine distribution period, demand for dry ice became so high that many airlines were forced to place special limits on how much of this ice could be carried on board. That may sound strange, since dry ice was being used to keep vaccines at extremely low temperatures throughout transportation. But the problem was that dry ice constantly turns into CO2 gas as it evaporates. Inside the sealed cargo compartments of an aircraft, this gas can gradually build up over time and reduce the amount of oxygen in the air. That is why airlines had to carefully calculate exactly how much dry ice could safely be loaded onto each flight. In the end, something designed to preserve vaccines also became a material that the aviation industry had to strictly control for safety reasons. From an invisible gas floating throughout Earth's atmosphere, humans discovered a way to turn CO2 into blocks of dry ice, cold enough to preserve vaccines, transport food across continents, and create fog effects that look like something from a science fiction movie. But perhaps the most fascinating part is that this material, which almost never exists naturally on Earth, is now quietly used throughout modern industry, from airports and factories to medical laboratories. And in the future, as cold storage technology and global logistics continue advancing, dry ice may become even more important than it is today. If you enjoy discovering the strange stories hidden behind everyday things, don't forget to subscribe and turn on notifications to keep exploring with Mido Explained.